Good afternoon, everyone. Today we will try to understand about the basic concept of climate changes, and in later classes we will be going to discuss about different approaches adopted by scientists to understand climate change. So, before going to the main theme of variations in climate, we need to understand the very concept of what is climate and weather. Most of what we know now consider common knowledge about weather and climate patterns was described by Thomas Jefferson, as you can see in the picture, and his jealous record keeping provides current climatologists with a lot of past information. Though Jefferson didn't know it at the time, he was actually measuring two different but related types of data. The short-term atmospheric conditions, the top one in the picture, the short-term atmospheric conditions are what we call weather, and these are all the daily, hourly, and monthly data he collected. The second data, the long-term atmospheric conditions, are what we called climate, and these are those short-term weather conditions averaged over a long period of time. Do you check the climate report for the day's temperatures and rain forecast? As you can see, different forecast, weather forecast map and all these things, you may be what you call encountered with this type of thing, or probably not. You check the weather report, you can Google it, you can find this type of data. Suppose, for example, if you want to look at the average temperature of any place over the past 100 years, just like the graph in the third picture, the blue and red bar graph, this would be the climate of that place for that period of time, because it is extended for several periods of time, several years. However, if you want to look at the condition for each month, day or hour, this would be the weather of that place for those shorter period of time. So, as you can see, though weather and climate describes different things, they depend on each other to have any sort of meaning. Think about it this way. The specific weather of any area depend on the climate, and the climate is the average weather condition for that area. Let us understand this by some example. If you were going to visit Delhi, the content of your bag would be a much different look and would depend on the time of year you visit. In the first picture, the summer of Delhi. In the summer, you might expect cooler temperatures, drier air, and less rain than in the tropics. You expect, maybe. Or you may expect, if it is Delhi in summer, very high temperature, dry air, heavy rainfall. In winter, it would be definitely the second picture. What you definitely you want to pack your heavy jackets, hats, and gloves, since there tend to be a lot of what you call fog and a lower average, very lower average temperature. The climate in Delhi changes with the seasons, but the weather throughout the season would be any daily change. Now here you are getting confused, I think. So you know what type of weather to expect in different places and at different times of the year, because you know the climate. Got it? But if you want to know if it will rain today or what the exact temperature will be for today, that's the weather. Again, if uh, you know what type of weather to expect in different places, suppose in case of Delhi here example, and at different time of the year, because you know the climate. Got it? That is what climate is. It's for long period of time. But if you want to know if it will rain today or what the exact temperature will be for today, that's the weather. Got it? So, do you experience the hourly, daily, or monthly variations in your weather? I think yes. But change in climate, do you feel it, experience it? The following discussion will answer the latter question. In the late 1950s, Charles Killing, as you have seen in the picture, he is Charles Killing. He started to measure carbon dioxide in atmosphere of Mauna Loa mountain in Hawaii, the second picture. So from his measurement, he observed two trends. In both of the graphs, you can see the trend. Actually, these two graphs are showing the same, what you call two trends together. They are the same graph. So one is that there is seasonal variation. As you can see, the graph is fluctuating within year 2009, 2019. So there is fluctuation. So a lot of carbon dioxide is released back into the atmosphere while in the spring, and carbon dioxide is sucked up by the trees. That is why the seasonal variation is there. There is ups and downs in carbon dioxide content in the atmosphere. But the second observation, the overall trend, as you can see in the third picture, the black line, the observation is that there is a long-term increase in trend of carbon dioxide concentration. So even there is fluctuation, seasonal fluctuation, the overall trend is increasing. From the graph, you see that the red line, the fourth picture in the brown what you call the brown colored graph, and there is one red line you can see, was transgressed in 2013, which means that is 400 parts per million of carbon dioxide is in the atmosphere. So this is very dangerous trend. Let us look at another example. An ice core miles deep was drilled in Antarctica to reconstruct from these ice layers about how the ancient atmosphere looked like. So after this what do you call work, the reconstruction of CO2 concentration in the atmosphere was done over the last sort of 800,000 years, and from the study shows fluctuating trend of ups and downs from this study also. Uh, that was another study and this was another study. Here also it is shown that there is fluctuating trend of carbon dioxide concentration across different periods of time since 800,000 years back. However, there is huge spike over the last 200 years. As you can see in the first graph, there is sudden increase in the concentration of CO2 in last what you call years, last 200 years. It crosses 400 parts per million. This will actually have a major impact on what they call the paradise of Holocene. So we will be going to discuss about the Holocene concept in early what you call later slides. This is now a chart, the second one, which tells you how the global mean temperature looked like over last 100,000 years. And you see it during the ice age over major fluctuation. The second graph, there is fluctuation in temperature. So the temperature dropped by 10 degree or something, again rise up like this. And finally around 11,000 years ago, it became very stable. The last part of the graph you can see after around 11,000 years ago. And this actually gave birth to what we call the Neolithic Revolution, because Homo sapiens were settled down, which was only possible because it was very stable climate. Okay. So To define climate change, literally, it denotes to long-term change in the statistical distribution of weather patterns like temperature, precipitation over decades to millions years of time. Climate on Earth has changed on all time scales ever since long before human activities could have played a role in its transformation. But UNFCCC defined climate change as a change of climate which is attributed directly or indirectly to human activity. That is very important. And that alters the composition of the global atmosphere and which is in addition to natural climate variability observed over comparable time periods. However, the IPCC definition of climate change includes changes due to natural variability alongside human activity. The term climate change, however, through definitions, policy propagations, qualifies as negative anthropogenic climate change. This is very important at present time. So when we talk about climate change, we always talk about negative anthropogenic, means the negative increasing temperature, decreasing sea level, or sorry, increasing sea level, decreasing ice cover. So this is a negative climate change in its present meaning. At the onset, it did not really appreciate its harmful brunt. So as we have discussed that there is long-term change in climate, let us look at that long-term. Now, the Earth's climate is always changing, so we cannot cover 4 billion years in our 6-minute tour. So let us look at some major periods in Earth's climate history. This study of ancient climates is called paleoclimatology, to be noted here, and it's demonstrated the Earth's climate is constantly changing as a result of gases in the atmosphere, cycles of the Earth in relation to Sun, and other factors. So from the beginning of the Earth's history, we have got period of extreme heat, some of extreme cold, but let us start here. The Cretaceous period, the first one. It's the period of dinosaurs, as you have seen in the picture, the first picture. It is about 70 million years ago, and the current global temperature is roughly 82 degrees Fahrenheit. During that time, the Earth itself is radiating that much on average. So it is hot, humid, and muggy. And such temperature was good for dinosaurs, not as great for mammals. Now we will jump to the next period, that is Pleistocene. It's lasting from the second picture, you can see the second stage. It is not just second stage, but we have shortened it. This period is called the Ice Age by many. It's roughly lasting from roughly 2.5 millions to 11.5 thousand years ago. An extreme drop in temperatures to a global average now, peaking at highs of 42 to 51 degree Fahrenheit, and led to a period of repeated cycle of glaciation, during which having far turned out to be pretty advantageous and mammals thrived, but not dinosaurs. Okay, so the mammals can actually live in this temperature. Now we will jump to the next, as we have mentioned in our earlier slides, the Holocene period. This is very important for this climate change aspect. It's a geological period dating from roughly 11,500 years ago to present. While human evolved in late Pleistocene, remember this, human evolved in the late Pleistocene, the Holocene saw the first rise of civilization. So this is the period of the in the picture, the last picture. Okay, so this is the period of human history. It's marked by dramatic shift in global temperature as a result of mostly of our positions in major cycles of solar radiation. Researchers estimate that there have been as many as 20 climatic cycles during the Holocene so far, but they can summarized in three major events. Let us look at these three major events. The most important thing is about the last century. Obviously, the climate changes all the time. So what's the big deal about climate changes in the last century or so? Well, it's not just a matter of the increase in temperature, it's a matter of the rate. So earlier the rate of temperature change was quite slow or fluctuating up and down, but during the last century the rate of change of temperature is quite what you call sudden, very high. You see, since the advent of major industrialization efforts across 20th century, the average global temperature went from steadily rising at a normal rate of skyrocketing. The current average temperature is warmer than it's been in the last 11,000 years, and the startling thing is that roughly two-thirds of that increase has only occurred since 1975. So that's a first change. Now, when temperature increases over thousands of years, nature can adapt, is not it? But this change is outpacing evolution. In the geological record, we have seen major changes that come along with rapid warming trends, including droughts that kill off large amount of plants life, massive tropical storms as we are experiencing right now. What you call the rate of these tropical storms are increasing day by day, and that completely reset coastal lines, and that's with global warming that occurs from natural causes. So the incredible fast climate change of the last 50 years is cause for concern. It may not seem like a big deal now, but when we look back through the history of our ever changing climate, we can see exactly what this could mean. So the Neolithic Revolution, just I added this portion. The Neolithic Revolution happened, so agriculture was invented, and this was the basis actually for the second big revolution in the history of civilization, namely the Industrial Revolution. So you see, in the 19th century, factories were being created. Now this all has to do with the burning of fossil fuels. In the beginning, coal, later on oil, natural gas, and you see still a little bit of biomass, nuclear energy, renewable energy also nowadays. One is that they are limited. We cannot go on forever, and the other drawback is that, very important, that the emission coming from burning of fossil fuels are changing the atmosphere. Now, if you look at just the last 100 years or so, this just demonstrated that each of the last decades was warmer than the previous one, and there is quite a difference. So clearly, the planet is warming, and it's due to human interference. So I think you have now the idea of what climate change is. So in the next class, we'll be trying to understand about how scientists try to look at climate change from different angle. Thank you very much. Have a nice day.